Can you hear me?
Yeah. Can you
Okay.
hear me? See me?
Yeah.
Can you see me? Okay, I think you can see me. You can hear me. Good. Thanks.
Good, thanks.
Hello, Jérôme. Hello, everyone. Just testing if you can hear us on the online tool.
Hello, Laurent. Hello.
Okay.
Yeah, I can hear you very well. Yeah. So I think we can start now.
Yep.
So hello, everyone, and thank you for joining this interim online meeting of the Network Management Research Group. So I'm online with Laurent Siavaglia. So we are the co-chair of this research group. So before we go into the technical content of the meeting, let me remind you the different noteware that that applies to the group as well. So the first one is related to, so just reminding you that IETF follows IETF intellectual property rights disclosure rules that are explicitly written here, and that you have also reference to the different documents. So in particular, please take care that if there is something you discuss that is covered by a patent, or that you have a patent or a patent application, you must disclose that in a timely manner before the meeting. So of course, please really refer to the document for more details regarding these different rules. Although, as many of you know, but it's good to remind, in particular for newcomers, you have to be aware that IETF routinely makes recording of both the online and in-person meetings. So it means that this meeting is recorded, and that the recording will be published online afterwards. So basically, if you turn on your camera and your microphone, it means implicitly that you consent to appear in such recordings. A very important noteware relates to the privacy and code of conduct. So the first point, just a reminder about what I've been said about the recording. But what is really important to see here in the slide, of course, is different links to the full text, but we want to remind that we all agree to work respectfully with other participants. And in case you have question or concern, you can contact the ombuds team. So please also consider the RFC, Code of Conduct and anti-harassment procedures. Let us remind you that the goal of IETF is to conduct research. It's not a standard development organization, so IETF is focused on longer-term research issues related to internet, while the parallel organization, the IETF, focuses on shorter-term issue of engineering and standard making. While the IETF can publish information or experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocol, application, architecture, and technology. So here is a link that have been provided to you already on the mailing list, and the important point is the last point here with the notes. So please feel free to help us to take notes during meeting. That will be really helpful as well. So regarding the agenda of the today meeting, so after this short introduction, we will have three technical presentation related to I would say, the data topic that we have started to investigate a bit in NMRG in the last month or years. So it's a kind of continuation of some presentation we had before in the last IETF regarding data quality, but it's also more open to general, let's say, research challenge or research problem related to the use of data and network management. So after this free presentation, we'll do a short wrap-up with Laurent on this topic. And of course, the main objective of this meeting is also to open the discussion to try to somehow outline or refine some part of the agenda of NMRG regarding these different problems, and also try to find a way to work collectively on research related to, let's say, data use in network management. So before we go into the different technical presentation, if you have any comments, or Laurent, also if you want to add something, please feel free.
No comment at the moment. Looking forward to the technical presentations.
Okay, perfect. So so we start with the first presentation from Ashley about data descriptors and topology in decentralized learning. So we'll stop sharing, and I think Ashley, you can directly share. Yes, perfect.
Hi everyone, can you hear me?
Yes, perfect.
Excellent, good. So let me actually share my slide. Can you see the slides?
Not from my side. It was saying sharing something, but then it disappeared.
Stop sharing. Well, it's still sharing, but I'm not sure where.
I can share. I think the
yeah, sure. You can, if you want, you can share, and then I can ask you to switch the pages. Yeah. Snapshot slide. So just as Jerome, thank you very much actually for bringing it up. Thanks everyone and for the opportunity. The presentations here, I'm not going to actually provide any solutions today. We started embarked on this research about a year ago, and we have actually, as we go through this, we have more questions than answers. And last time we talked with Jerome and Laurent in Dublin, they offered kindly that we can actually bring this topic to the NMRG and see whether people are interested to actually work on this topic and conduct research and basically help with the overall progress of this thing. Next slide, please. So data descriptors and topologies in decentralized learning. This is an initial views and some potential requirements. And again, nothing basically is set on stone yet, but it's just a beginning of the research. Next slide, please.
I think you should have the control of the slide.
Oh, should I? Oh, okay.
Yeah,
yeah, sure.
Perfect.
All right. Okay, yeah, sure. So we'll start with some quick background. So we all know that today, for example, most of the models, AI models, are being trained in a centralized fashion, and essentially large volume of data, they're collected and are processed in central clouds. This centralization basically is facing some challenges. The cost has been increasing due to a couple of factors. The growth in model and the data volume is a concern right now. And then the need that we have to retrain the big models and consume more data when the new data arrive to integrate and avoid forgetting earlier knowledge is basically another thing that contributes to the cost. Privacy, of course, is another factor that has to be considered as data is lifted from the nodes and are brought to the data centers. There are some privacy concerns, especially in Europe, that might not fit the bill. And then there's some communication costs, of course, that we have to actually move the data around over and over again. So this decentralized learning methods now, such as federated learning, gossip learning, split learning, continual learning, etc., they have been picking up some momentum, and they have sort of found themselves into some applications like healthcare, for example, where privacy is pretty high, and some mobile networks as well. So a little bit about decentralized learning. They're basically trying to aim for the same performance as a centralized approach while improving scalability, privacy, potentially reducing communication and storage requirements. So in these methods, generally, when you look at the overall decentralized learning, they usually follow the model follow data paradigm, but in which the underlying knowledge network consists of number of nodes with data. So they either have access to the data or they own the data themselves. These nodes or this data, they collectively constitute the global data corpus, which is a global database of all the data available in the network. And then what we do, we basically move the model around for training from nodes or as in federated learning, in many times we go between the aggregators and the clients to get our training. The big question, though, in these systems is that how do we identify the relevant data nodes with respect to each model in these knowledge sharing networks? There have been some simple decision-making parameters such as node data size, data type, and the compute, storage, communication capabilities, etc. But these parameters, they are not alone very sufficient to actually do the work. They ignore two things: the characteristics of the data itself, which is very important, and the model architecture, basically how it plays a role in these overall training sessions. Now, what are the factors that we're looking for? That data characteristics, of course, is playing a big role. And what do I mean by data characteristics? Data type, size, distribution, and important factors, these are all good. But they lack the necessary details to sufficiently describe and differentiate data at each node from a node's perspective, from model's perspective. The information such as data quality, data age, data dynamics, evolution, and rate of change over time, for example, data variance, and its relevance, the overall relevance of data to the model are additional factors that are required and they must be considered when we are actually trying to train the data by sending it to, for example, data nodes. But the question is, how do we actually define data quality from a model training point of view? As an example, a picture resolution is one metric, but doesn't really say much about knowledge quality. We don't know what we're going to get out of that picture. So the question is that, is there a function that takes raw data as input and generates a meaningful output that can be used to differentiate quality of different data sets with respect to each node, right? So can one function, for example, fit all? Or do we actually need different functions based on data categories and other characteristics? How do we do this without revealing too much or any of the raw data altogether? What is the impact of the model architecture and characteristics here? Some of the early research that we have done so far, it shows that we cannot actually look into this in the vacuum. So the answer to the above question is a quantitative and qualitative data descriptor, which can be used to differentiate data at each node, but it has to be per model. One build doesn't fit everything. So the data has to be considered with respect to the model. They are tied together. They're tightly coupled. So data dynamics, what are these? So data evolution basically is one of them. Changes in the state of the data in data set at each node over time. What's get added, what's get deleted, what gets modified. These are all important factors that we have to know about. And they have to be communicated. What changes are important from a model point of view? Is history important? What is the rate of change? How fast and how slow these changes are happening? Do we need to consider every change, or we should consider sort of a threshold and before or after which we don't care? So data variance is, as I said, is another one. Understanding data scope with respect to a model-based reference point. For example, if we ask if you want to know about the black cat, for example, well, the question is the black cat, this notion of black has a range and it's ambiguous. So we need to somehow, tame this. Data age probably is the simplest one, but it's important as well. It comes to picture when data relevance is tightly coupled to data generation time. In some scenarios, for example, models might need training data from a specific time frames. Similarly, this is similar to quality. We need a method to measure data age specifically for newly submitted but older data. This is probably the low-hanging fruit because a simple time stamping seems to be actually working. But the point I'm trying to make is that to understand the major data dynamics, we first need to be able to express and describe data from models' point of view. And that's what I meant by data descriptors. And later on, we see how it fits to topologies. So architecture, as I said, this whole thing cannot be seen in the vacuum. It has to be, the model comes to a picture. So model size, capacity, structure, and parameters are important physical model characteristics. So these characteristics must be considered when interpreting these data measures. So suppose that we come up with these data measures, then we have to tie them up to the models and see what works in there. There are also other factors when it comes to model that only reveal themselves when training begins. And we have already seen that models with different architecture trained on the even same data sets can produce different results. A field, NAS, for example, neural architecture research, is a field that is trying to match model architecture to data sets for best performance. And I will talk about this when we go to Bangkok, for example, and we'll see how we actually use this in our early research and give you some more details about this. But the work is basically is showing that data characteristics cannot be considered in a vacuum and are coupled to models architectures and training objectives. So what factors need to be considered during this training? How do we discover this coupling with no or minimal training? What is the measure of this coupling? These are all the open questions that I'm trying to actually bring to the research community and see whether collectively we can get answers to them. So the point is that mindful selection of training data from the corpus with respect to model architecture can result in better model performance. Data descriptors, they have to play an enabling role. So whatever method that we come up with to describe data, it has to be enabling us to actually do these type of things. So training methods and algorithms, of course, this is another important factor. The training methods and data dynamics sort of like are tied up together. The rate of change in data, for example, can sort of like dictate the training method. A very crude example is like federated learning, for example, lends itself better to faster data variation rate, whereas sequential learning, for example, on the other hand, can adapt better probably to a slower rate. These are just some preliminary observations. Performance of training algorithms is also dependent on the data characteristics. So depending on how we're going to train the model, this relationship so far only reveals themselves during the training time. So until we actually train the model, we really don't have a clue whether one training algorithm is better than the other one for this thing. It's sometimes the statistics that we collect, and we basically say, well, based on our previous experience, we have figured out that this algorithm is better than the other one, but there is no really a scientific way to go about it so far. So how data descriptors can help express data characteristics that facilitate this task without or minimal training, that's the main task here. So data descriptors, they must contain attributes that enable mapping of training methods and algorithms to optimum training data sets. Very tall order of the requirement list. So the final point is that I'm trying to make is that decentralized learning has a lot of moving parts that require careful optimization for good performance. What the model can learn from each data node is the ultimate question. And how can we do this without or with minimum data transfer? So we need knowledge information from each node. We need a mechanism to express knowledge. This is actually the crucial objective of our data descriptors. But aside from, even if we don't go with decentralized learning, even for centralized learning, this approach of describing data actually will help a lot, because right now we are blindly collecting a lot of information and we're bringing them to the data centers, the clouds, and then we crunch all the data sets that we have and then train the model based on everything. By carefully selecting the data sets, we can actually reduce the overall purpose that the centralized learning basically use to train its model as well. So it's not only applied to the decentralized, but the centralized approach of training actually can benefit from this. Now, once we have these data descriptors, if we have a suitable data descriptors, what can we do with it? So these things will help us develop data comparison metrics. So now that I have a data descriptor, I can actually compare data sets with each other and say which one is better than the other, or actually I can create some sort of like a metric to compare them with each other. So they enable us to precisely differentiate data on different nodes. And now what we have here now, we can create a knowledge network data topology for these networks. What we do with this topology, now we can use this topology to solve some challenges in AI research, such as node selection, path computation, and catastrophic forgetting, for example. We can tackle these problems a lot easier if we had these data descriptors. So the picture at the bottom of this presentation sort of shows the vision behind data topologies or knowledge network data topologies. So each dot basically corresponds to a data node, and the edges basically are telling us the relationship between the data on those data nodes. Once we have this, now we can actually achieve the last bullet, which is basically path selection, data node selection, in terms of if the data rate is, for example, slow, we can do entire path selection, even in the decentralized or sequential learning as well. So with that, as I said, like I have a lot of questions right now. I just wanted to make sure that I bring this to the research community and see whether I can entice people to start thinking about this, and together maybe we can actually bring some ideas to IETF, and hopefully then design some other methods in IETF to help us going forward. That's it for me.
Thank you very much. So do we have questions?
Mm-hmm.
Okay, so Laurent, you're first.
Yeah, thank you, Rashmid. I really like the presentation. It triggers a lot of thoughts. Maybe can you go back? I think in one of the slides you have something about. I think it's. Can you go up slowly? I will. I don't remember. No, next one, please. Next one. Next, please. No, this is the one. Yeah. No, slide 6. Yes. On the first bullet point, I mean the second, you have these models characteristics must be considered when interpreting data measurements. I felt a bit to capture what you mean here, because for me those things will be a bit independent to my knowledge.
Right. So when we did some testing actually on this, and actually we are in the middle of the testing, and so far we see that. So for some basic measurements that we have done, which is, by the way, we are still lifting data, and I talk about this a bit more probably in Bangkok about what the network looks like. The model actually that we have will make a difference. So if I have the same data set, for example, and I train two different models with two different architectures on it that aim for the same thing, they train differently. They produce different results on the same data sets. And the performance and the performance that we get out of those, I mean, precision that we get out of those things are different. And I'm talking about architecture difference. I'm not talking about simply size. Size really matters. Size basically will bring some interesting aspect to the system. LLMs, for example, have proven those. As soon as we increase the size to a certain point, then these LLMs started exhibiting some interesting, new behaviors that we did not anticipate. But I'm not talking about those. I'm talking about the actual model architecture. How many layers we have? The nodes could be the same, but the way we put them together could be different. And those, for the same data set, seem to have a different meaning.
Thanks. Maybe just to clarify a bit what I was after is that, you see, the last part we say when interpreting data measurements. What I'm trying a bit to figure out is, as you were saying, let's say we have one single data set and we train different models. Out of that, we get different kind of output. Okay, and when we, let's say, try to run inference on the models, we can get different outputs. And what I got from your point is that we need to be careful that the input we got needs to be also kind of correlated with what kind of data we had at the beginning. And this is why, for me, I will see a bit of independence between that. And when you say interpreting data measurements, I wasn't sure which kind of data measurements.
So what I'm saying is that, let's say I have two nodes that I'm comparing to each other, and each of them has a data descriptors. So if I describe the data on node A and node B, this whatever data descriptors that we have, it cannot be just considered solely based on the data set. We can say this data is different from this data by this much. The model comes to a picture here. The data cannot be independently considered without the model. This measurement that we made cannot be in a standalone measurement. So we measure it with the measurement that we have is not only for data, but is coupled to a model itself, because the model is going to use this data. So model, brings another dimension to this, which we cannot ignore. So I cannot simply say this node, the data on this node is different to this node by this much, because we are not considering the model. There is a third factor that we have to. So this node data is different from this node data with respect to this model. So unlike our networking, for example, that we create a linked state database and the topology is global, the topology here, we have a corpus that is global, but the topology is model-based. The model, the topology that we create cannot be created in vacuum without considering the model.
Mm-hmm. Okay, I think I got a bit what you are after, but okay, I suggest I take it also offline with you to run some.
Sure, absolutely.
Yeah, I think I got what you were saying. Okay, thanks.
Yes, Jose, please. Jose, we cannot hear you.
Jose, you want to?
I think he got disconnected.
Oh yeah. Okay. So I will continue because I have also one question or questions and comment actually. Thanks for the presentation. It was very interesting, and yes, it somehow touches different also personal activities that I'm working on regarding data quality and data description. I think one important point that you highlight is how we can be able to map data to a certain type of frame to know if the data is appropriate to, for example, train an algorithm to resolve a given problem. And I think this is really, really important. I think some part of this is related to how you can qualify some of the data for a certain type of problem. My comment is that it's most of the time something that we try to do, I would say, in general in the community. So we produce data for a particular needs. Okay, for example, I'm working on network security. We produce data, assuming that it will be used for evaluating some intrusion detection system. It's good that we can do this somehow, this mapping, and such somehow the description of data in that sense will provide this description and so this mapping. But it's hard to say for what the data cannot be used. Of course, you can say it need to be only used exclusively for a certain type of problem, but some it could be used for other type of problem, and this is very hard to achieve. And by pushing, I have the impression that if you say that everything will be somehow given by data descriptors or data description, it assumes, or it pushes a lot of pressure somehow on, let's say, the producer or provider of data that need a very clear, a very clear description of the data itself. Whereas they cannot really assume all potential usage of the data can be needed. I don't know if you see my point. Is that somehow, I think, kind of imbalance to have a very, let's say, helpful or strict description of data, but for people working on data or producing data, they do not have necessarily the knowledge of how the data will be used. And some of my question, should we need also to have some kind of a counterpart where we need a kind of application or model or whatever description, as you said also here, and then some kind of mapping between the two. That is not somehow, I don't expect it would be one-to-one. So here there is a kind of probably some research question. How you map, for example, data description is a problem description that use AI. And so just to maybe have also the counterpart, it's not only, in my opinion, not only about the description of the data, but description of the problem. You cannot expect the data exactly describe all the problem that can be used. So it's just more common.
So Jerome, are you talking about the data quality in terms of measuring the data quality? So the point is that if we come up with some sort of descriptor, then the data quality then is based on these measurements, right? We have to have that notion of data quality. Right now, without any measurement, we cannot say how this data is better than the other one.
Yes, but as you say, this data quality is very dependent on the model you will use or the type
exactly.
of and so
exactly.
It means that the data description itself, if you have only, in my opinion, if you have only data description, you cannot guess all the type of usage of models that will be used with the data.
Right. So that's why I was trying to actually, that's what my point was that I sort of like explained there to Laurent in terms of, so just if I have data descriptors by themselves, they are not revealing much. I cannot actually say that I have to bring the model into picture. So this data quality is with respect to the objective of the model as well, right? So we have to consider what KPIs the model is trying to achieve. And in that context now, the data descriptors can enable us to understand, for example, the quality of one data set versus the other one for this particular model and the KPIs that it's trying to achieve. So you're absolutely right. If I go with data descriptors, they're not enough.
Yeah, exactly. And that's somehow in kind of my comment was that, but yeah, this assumes that you are able to somehow test the different data set or data description with the same models. So it's supposed that models are somehow shared, right?
Mm-hmm.
Okay, I see.
So right now, quite frankly, I don't even have a clear picture of how these data descriptors are going to look like. For example, I tried data distribution, but data distribution is not a very good indicator because what does some data set tells me if the distribution of dogs, for example, picture of dogs in it is this much, and the other one has a cat? It doesn't give me any base of comparison, for example, right? So so I would like to start with something simple as a basic initial view of a data descriptor, and then we keep experimenting with this and see how far we can push the envelope.
Okay. Yeah. Okay. See. Thank you. I will.
You're welcome. As I said, when I come to Bangkok, I will actually show you guys, like hopefully during a session, what type of setup I'm having and what's the vision is. There is also a vision paper that we have already submitted to the archive, and it's submitted for review to IEEE magazine. that shows some of the vision for the application of this work. Once we have this data measure, what we can do with it, and so on and so forth. So I will post it online on the mailing list.
Okay, perfect. Thank you, Arushin. I will let Jose asking the question, because I think now it's connected again.
Okay.
Yes. Can you
Yes,
hear me
I
now?
hear you. Yeah, perfect.
Okay, brilliant. Thank you for the presentation. It's a very interesting topic. I was wondering, I think this to the other questions. In our own work, we have used also models as a way to have a kind of a proxy for data quality. I think there can be some data quality measurements that are not related to the specific model, but in very more demanding situations, using models as a kind of a proxy for assessing the quality of the data is, at least we have been working on that. Yes. I was wondering then, okay, I see this triple relationship, data, model, and node in your case, because you have this decentralized learning. So I was wondering, which is the main goal of these data descriptions? I understand that it is not general data quality. So it could be data model quality relationship, or are you aiming to use it for node comparisons?
Right. So if I have, as I said, it's basically here in this picture. If I can have this descriptor, my hope is that using this descriptor, I can create a network data topology for a model, and based on that data topology, then I can actually select a set of nodes that are suited to best train this model. Now, either in a centralized fashion or a distributed fashion. So the aim is to reduce or at least carefully select the data set for a particular model, to reduce at least some of the data sets that we have, and we don't look at every garbage. For example, if two nodes, like in a very crude manner, if I somehow come up with this data descriptors that put two nodes very close to each other, this notion of closeness can be interpreted as these nodes basically have similar data. Therefore, I don't need to actually train the model on both of them and spend time and energy to train the model on both of these nodes. If I train this model on one of these nodes, I will achieve my objective as a collective two nodes. Now, playing a double advocate, the differences cannot be ignored either, because one of these nodes or the other one can have such an important data that if I miss it, then I miss a corner case in my model training. So this is a type of thing I'm trying to actually figure out with data descriptors.
Okay, that makes sense. Thank you.
Jerome, you're next.
Yes, I think I just forget to. Sorry.
I may have maybe also looking at the time, but just a quick maybe questions. We can take it later because when I was listening to your discussion with Jose, the point is you see right now mainly an application for machine learning. I mean, from this, let's say, data network. But potentially, we could use it also for other network functions or network automation.
Absolutely, yeah.
Okay, thanks.
So I'm thinking about, Laurent, I'm thinking about actually the mobile network and GNodeBs. Right? So imagine GNodeBs of the data nodes, and they are collecting ISAC data. And the operators are basically getting models for training purposes. So what GNodeB I go to train my model, or what GNodeB I collect the data from to train this model?
That totally makes sense. I was just thinking that, I mean, beyond, you see, the purpose of having information on the data nodes for, let's say, matching with models and training, or even maybe inference. I was thinking that if we have those data pockets and we have descriptors of that, they can also be used to see if you have certain network functionality or optimization. You say, okay, they could also, like we have telemetry today, but with additional description to say, these are the right data that you can use to, I don't know, run an anomaly detection or.
Exactly.
Yeah. Okay, thanks. I was just thinking like, thank you.
Okay, so thank you, Rashmin, again for the further presentation. So I think so will be a full application and mailing list on next IETF, and of course at the end of this meeting as well. So let's move on now to the second presentation. So I invite Benoit.
Hello. Can you hear me?
Yes, I can. We can hear you very well. And I will just share a slide and give you the. Okay. And so now, Benoit, you should have the control of the slides.
Okay, thank you. Okay. Hello, everyone. My name is Benoit Nyanke. I am a postdoc at Telecom Suite Paris, working with Grégory Blanc and Thomas Robert on evaluating intrusion detection system datasets within the supervised project, a French project on security, supervision, and orchestration. Today, I will talk about our initiatives on evaluating network intrusion detection system datasets within a systematic evaluation framework. Okay, for my talk is structured in 3 main parts. I will provide a quick background on intrusion detection system and mainly the challenges faced with their datasets. Then I will propose our approach for evaluating this dataset. And in the last part, we will use the diversity characteristic as one of the quality measure of these datasets. So network intrusion detection system are tools for detecting suspicious activity on the networks by analyzing packet headers or flow records, and also by correlating network traffic to trigger alerts, and those alerts may be later analyzed to make decision if that was really an attack or new activity on the network. Unlike the traditional intrusion detection system based on signatures, the ML-based one aims to detect unseen attacks by learning complex network patterns. However, their effectiveness relies heavily on the quality of the data. That's one of the main topic here, how to describe or evaluate the quality of the data. And mainly for the network intrusion detection system, the dataset may impact the generalization of the learned model to real network conditions or scenarios. So this leads us to question how network detection intrusion detection system batsman datasets are constructed and where they could fall short for ML-based system. Typically, this dataset comes in form of labeled data to distinguish between legitimate traffic and the malicious one. And typically, they are presented in a flow-based form that aggregates packets over a time period. And also, we generally have the packet-based form followed with the dataset in a pickup form with more information or more details. Some survey provide an overview of existing NEDS and IDS datasets, mainly at a high level, discussion qualitative criteria, mainly the generation environment, data nature, data volume, and so on. But within our project, we aim to go beyond the qualitative aspect and include more quantitative criteria in the context dimension, collection process, and also the data properties with regard to the usage or the model, as we saw on the last presentation. So our main purpose here will be the data set quality with regard to their usage later. However, we have to discuss some of the specificities of the dataset within this field. Firstly, unlike some datasets in other fields, like in computer vision, for example, ImageNet, network intrusion detection datasets often come from simulations, and they are less representative of some real-world scenarios. And on top of that, some errors have been discovered of some of the mostly used datasets. These issues include generally labeling errors, overcorrelated features, or misordered packets. All these observations question the validity of or the reliability of ML-based model trained or evaluated on such datasets. So all these elements motivate our work of evaluating these datasets prior to their usage. So this brings us to the second part of the presentation on our proposed evaluation framework for these datasets. So the idea here is to use quantitative metrics to provide insight on the characteristics of the datasets and to provide valuable information before their usage. So before providing more detail on our framework, I would like to present this existing study on bad design smears in network intrusion detection datasets. That studies some of the intrusion detection datasets, and they discovered some suspicious patterns that they called bad design smears, or simply data smears, or simply bad smears. For these bad smears, they propose some heuristics that scales from 0 to 1 to measure the severity of those suspicious design patterns. And these bad smears are categorized in 3 main categories: mislabeling, poor data diversity, or simulation artifact. This heuristic represent, let's say, a good starting point toward our objectives. And we would like to build on top of these insights by providing more systematic or formalized way of measuring the dataset's quality. So for that, we will rely on measurement theory that help us to translate the abstract characteristic of datasets. Generally, the quality we want are diversity, realism, and so on. We want to translate those abstract terms to concrete and measurable constructs. and later we could evaluate their reliability or validity. And within the measurement theory framework, we could do this in four main steps: the conceptualization, operationalization, reliability, and validity. So we are adopting this framework, and we are building also on prior work in the ML community, where Zhao and others, and also Michel, emphasize the necessity of having formalized data measure for ML datasets. So now we will see what are the existing data measures that we can use. We can use that we could improve to use within this measurement theory framework. Michel categorized some of the existing data measures in 5 main categories, like distance, diversity, density, and so on. And we can also distinguish between general measure, or let's say the generic ones, like Euclidean distance, Venn score, for example, for diversity, or also some modality-specific measure, for example, the inspection score for computer vision, or the perplexity for natural language processing. When it comes to intrusion detection system, data modality, the main measure used are the distance or similarity measure, especially Euclidean distance, cosine similarity, and also distance on probability distribution are also used. So we will see in which way we could leverage this measure when characterizing the datasets within the proposed framework. So now that we have our framework established with some of the existing measures, we will characterize one of the quality of the dataset, let's say diversity, using the Venn score. Okay, why diversity? Because diversity is one of the main characteristics we want to have for our datasets, and also because it is generally coupled with the model generalization. It means if we have a data with less variety, this may favor overfitting and limit the model's ability to generalize to new or a varied pattern of an attack, for example. So the first phase of our framework will be the conceptualization, where we define the construct for diversity. The key point here is to say that diversity is not just the different number of attack types we have within a dataset. This may represent a lot of more dimensions. For example, here we will take into account spatial or temporal diversity, intra-class, and so on. And to measure this construct, we will rely on the Venn score, a generic measure for diversity that will provide us with an effective number of unique elements in a dataset or a collection of n samples. And this Venn score will rely on a similarity measure. Here, let's say K. And this makes this metric flexible in the sense that we can use different functions of similarity for the notion, the way we want to define different or similar. So before providing some concrete example of the Venn score on an IGS dataset, let's see some of the inspiration of this Venn score from ecology. Ecology is one of the long-studied disciplines where diversity have been discussed, and They generally use some of the metrics like the Hill numbers or Renyi entropies, mainly using the number of species or species count, let's also call richness, but also the relative numbers of the species within the community. So for example, taking only into account the richness here, we may consider these two domains as equally diverse. But if we want to take into account the relative abundance of the different elements, we have to take into account some other aspects. For example, by including a sensitivity parameter to decide on how we want to be sensitive to rare or frequent elements in the data. And one of the other main element is similarity. So we have to take into account the similarity between those different elements or those species here. And the Venn score incorporates all of these aspects, and it will be useful for us to evaluate the data sets. So one of the examples on the CIC IGS 2018 dataset is here, where we try to evaluate the diversity on a subset of this dataset. We consider different feature categories. So firstly, we take into account all the available features, and we observe a diversity score of 6 for the legitimate class, and also considering all the attacks together, and a slightly higher value for all the sample taken as a whole. And we can also see how the diversity, how different categories of feature contribute to the diversity. And this is when we are using the cosine similarity function. For example, when using Euclidean similarity, we can distinguish more distant elements in the dataset, and we observe a higher score for the diversity of about 10K. So those results are the one for the sensitivity variable Q for value 1 here. At this point, we assume that the different elements in our data are uniformly distributed. But if we want to put emphasis on, for example, rare element, we will vary the Q towards 0, meaning those rare elements will contribute also to the diversity score. So here we can see that we have a more higher diversity score. But if we only want to consider the more frequent element in our data set, so we will use the sensitivity parameter close to infinity. And this plot of the diversity measure or the Venn score versus the sensitivity parameter is called a diversity profile. And we could use the diversity profile to compare dataset or for the dataset improvement, if you want to include, for example, more rare element or not. So the main takeaways of this talk are high quality data set are essential for ML-based network intrusion detection system. And we propose a measurement-based framework to provide structured way of evaluating the dataset's characteristic. And we provide an example with the diversity characteristic. As future work, we will continue with the Venn score to provide accuracy and validity of that measure and try to correlate this characteristic to model performance. Thank you for your attention.
Thank you, Benoit, for your presentation. I will give the floor to Omar, that is in the queue for question.
Yeah, so I have questions. Thank you, Benoit, for your presentation. And so you mentioned the paper about bad smells and EDS benchmark datasets. And I read the paper, and in the paper they also propose a metric called the repetitive data point, in which they quantify how much repetitive data point in terms of value of the feature are included in the dataset for a class. So you have a class, you have the data point of the class, and they also provide a metric called the repetitive data point, which like quantify how much the repetitive point include that class. And in your presentation, you also you read the paper, I guess, and you remember this
Yes.
metric. So and in your presentation, you also like if I understand correctly, you also propose to use the Venn score, which is a metric that also quantify like the diversity, which is for me the same as the repetitive metric that was proposed by the authors. So maybe I didn't understand the difference between your metric and their metric, and like you apply your metric on the whole dataset, which is like the same strategy that was used by the author of this paper. So maybe I didn't understand the difference between these two metric, yours and the metrics of the paper.
Okay. Yeah, thank you for the question. So our framework is building on some of the insight of these papers. So we are not completely in opposition with what they have made. But for me, for example, the metric they propose for data diversity is a metric to quantify the absence of diversity. For example, when you have a score of 0, it's for them, it's like, okay, probably there is no problem of diversity with this data set. And a score close to 1 means these data sets may have some problem of diversity. But in our work, so we want to go beyond that and provide a real value of diversity, how much diverse the attack class, for example, is.
Okay, so because the Venn score, is not normalized between 0 and 1.
No, it's not
It's
normalized.
possible to there is a way to normalize between 0 and 1, but used in a normalized way. It's not normalized.
Yeah. The Venn score is between 0 and infinity.
Okay. Just another question. When you mentioned some metrics that you want to propose for your framework, but like the idea is to quantify the dataset as a whole. But I understand like what is like the difference between what all other papers that worked on this subject. What is like the difference between what you are doing and what all other paper done on this subject? Because there is a lot of paper that, okay, we are going to propose metric, quantify quality, propose metric, quantify quality, and I didn't understand actually what make your work different from the others.
Okay. Thank you for the second question. So that comes from the main objective of the framework, which is that we want to link the proposed metrics to the right construct of the quality. Let me explain. So generally, we have some quality, for example, let's say diversity or quality, and there will be some metrics that will be proposed in the literature, like you are saying. But diversity or quality are very abstract terms, so it's difficult to agree on single definition for those terms. And for using measurement theory, try to bring a bit these gaps, taking a concept and proposing concrete definition. As hopefully we could agree on those definitions and then link the appropriate metrics to those those constructs. And also we have a systematic way of validating those metrics. If we are really measuring the quality we want to measure, or we are measuring another quality. So it's mostly putting some more systematic approach within how we measure those data quality.
Okay. Okay. Thanks. Can I ask a last question? And you propose so 3 metrics like diversity, realism, and complexity. If I'm not wrong. Yeah. So are you planning to to test this metric to test the impact of this metric on an IDS? So let's say you have more diversity. So what more diversity is going to bring technically on when applying it on IDS? So when you have more realism, so what is the difference that you are going to have on when using it on IDS, like in the real application? When you have more learning complexity, so okay, so let's say we have good score of learning complexity, what this is going to impact exactly on the application with IDS?
Yes, that will be one, that will be part of the future work, especially for diversity. For now, we are focusing on diversity. So depending on our definition of the construct, so we will not evaluate the characteristics just for the sake of evaluating them. For example, we expect that diversity is related to model generalization or false positive reduction and so on. So when we have our Venn score, the next phase will be to do those experiments and see if we could correlate this measure with the performance of the model, for example.
Okay. Thanks. And just last question, sorry. When you say diversity, is like diversity of one class or diversity of multiple type of attacks? It's just one class or one level?
So that is okay, I will not say power, but that is what is interesting with the framework, that we can define different notion of diversity.
Okay.
For example, here we can have different type of diversity. For example, spatial mean how the data points are organized within their feature space. That could be done intra-class within a class, or for example, the legitimate class, an attack class, or taking all the attacks together. That could be also a class, or between different classes.
Okay.
So we can define different notion of diversity depending on what we want to measure and what we want to correlate them to later.
Okay. Thanks. Thank you very much.
Okay.
That's all for me. Thanks.
Thank you.
Yes, thank you, Benoit. I have a question or clarification. If you go back to the workflow where you have this validation of, with these four bricks, sorry. Yeah, validity, assessing if frame measurement align with theory. Can you be? I know that it's not not directly your work, but can you just elaborate a bit more on this validity, or you can validate here what is meant by assessing if empirical measurement align with theory, and how is this possible to do, or what is proposed to do that? I do not see clearly how it can be done.
Okay. Yeah. So okay. Normally that will be the next step later, but theoretically, the idea here is, with the measurement theory framework, is to reduce measurement error. So when we have a metric, for example, the Venn score, we will use some different sort of measurement, and then try to correlate those measurements with some measurement error. So for one of the examples they provide to validate, okay, let me rephrase it. Generally, reliability and validity could be very close. Reliability, we will do the same experiment with the same metrics and see if we are getting consistent measure. So generally that are easy. But for the validity, for example, for the Venn score, if we have two different definition of Venn score, or if we find two similar metrics for the diversity, we will use those metrics on the same data set and on the same configuration and try to see if there is a correlation or not, for example. And if there is no correlation between two diversity measures, we can question the validity of this measure, if the measure is really measuring diversity or if the measure is measuring another concept or quality. I don't know if that answers it.
Yeah, I see. Yeah, I see. And maybe do you think that a bit kind of follow-up of Omar's question is that validity, for example, assuming that you work on an EDS dataset, and so basically your goal is to make the evaluation of an EDS more relevant or more robust, and it could be that you validate a metric by, as for example, Omar says that if you see that the complexity or diversity is increasing, then the error at the output of the IDS increase as well. Do you think that it could be part of such type of validity? I mean, I know it's beyond what has been proposed in this paper, but do you think it could be relevant to do that? Just using the output of the very last output of your algorithm, what you want to do, for example, detecting intrusions, and see if this correlates with the metrics that you define in the beginning.
Yeah, completely. So that brings us to the dataset and usage or dataset and model. So in this validity phase, we have to correlate the measure with the model. So for example, if in our definition of diversity, we say diversity is related to this performance of the model or this complexity measure, in this phase, we have to test that and make sure they are correlated, they are completely right.
Okay. Thank you, Benoit. Pierre-François, yes, please go ahead with the question.
Yes, thank you, Benoit, for the presentation. It was very, very interesting. I have a question about the actionability that you mentioned during the presentation. How actionable is the Venn score?
Yeah, how actionable is the Venn score? Thank you for your question. So this is still very open, but we have some thoughts on that. One of the or what we mean by actionable there could be, let's see if I have the diversity profile. Okay, let's take it this way. For example, I have a set of data sets with a diversity score. If I want to sample a part of the data set and keep the same diversity score or similar diversity score, I could rely on the Venn score, for example. Those are the elements we want to put there by actionable, for example. And also, if in the data set we want to, if for example we want to improve a data set towards rare element or more frequent one, using, for example, the diversity profile, we can rely on the metrics and see if we are able to do that. So there are some work on diversity-based sampling, and I hope we could rely on those type of work to do that.
Okay. Okay, that's all for me. Thanks.
Can I have a last technical
question?
Like when using the Venn score, because I use the Venn score and I noticed that is like highly computation expensive, and when it's like there is a high dimensional vector, because you have to build the similarity matrix between all the data point, and from the similarity matrix you apply other types of calculation. And how did you manage this? I'm curious, how did you manage to like avoid like this computational time, and or maybe you just wait, just to wait for the computation?
So far we have a problem of computation overhead for the Venn score for now. So we still face the same problem here. We have to wait long term, or we can't run it on all the data sets. So for example, here it's on a subset of the data set.
Okay, this is what I guess. Yeah, I guess it, because yeah, I was curious about how did you manage to like calculate on the world, because IDS 2019 is like more than 50 or 70 gigabytes of data. So if you apply the Van Discal on it, it's like it takes like months and months, or maybe months. Yeah, thanks.
Thanks again, Benoit, for your presentation. And it has, I think, has already asked a lot of questions, and plus some others. So let's continue with the last technical presentation for today. So the last speaker is Marilyn. So I will share the slide and I will give you the control, Marilyn.
Hello, can you hear me?
Yes, perfect.
Okay. That is the first time that I use this tool, so I hope that I will success. Okay, and I can. Oh, okay, thank you. So
you should be able now to control.
Yes, I see that.
Perfect.
So I will talk about first. Hi, everybody. I will talk about work that has been done inside the Nokia Research Center and presented to VTC 2023. The title of this work is Classification with Synthetic Radio Data for Real Life Environment Sensing. That in this work we have focused on evaluating the quality of data, but it is synthetical data. So we will see. This study has been conducted by now 2 doctors. In this time there was PhD students, and the works was supervised by me. The first part of this talk consists in describing the motivation, context, and solution. And in the second part, I will present the main results obtained in this study. So, in sensing enabled mobile infrastructure, the network acts itself as a wall sensor by leveraging radio data and signals collected within base stations. The data is exploited for development of data-driven machine learning solutions to augment networks' capability. Nevertheless, large-scale quality data is required for achieving high accuracy learning. However, the training phase of ML models leads to prohibitive cost and heavy constraints on data collection and transfer, and we can sell also on storage that are not desirable for networks. So we are interested in this focused interest. We are interested in the use case of real-life environment sensing that constitutes new sensing capabilities for 5G or 6G networks. And particularly, we focused on indoor-outdoor detection using unsupervised clustering models. We will investigate how generative models can help IoT in context of massive data collection. Thus, to overcome the cost issues and heavy constraints of collecting and storing data, we are interested in exploring the possibility of training ML models with only synthetic data, unlike unlike what we see in related works. And this solution would avoid carrying the raw original data from a point to another point, but rather a generative model. In other words, at a source node, a generative model is used for learning the source real data, and then the generator model or descriptor of this generator model is transmitted over network instead of raw source data to a remote node. Then, at this remote node, the system produced on-demand synthetic radio data to train ML models. To do so, synthetic data should accurately mirror real-world data. Before going further, just a short description of the use case of IOD. It is explained in the two successive slides. As you can see in the scheme, IOD consists to give an answer to the following question, which is the environment of a user when she is connected to a cellular network. The context is indoor or outdoor, and it corresponds to multiple environment situation. As you see in this slides, you can these slides illustrate the system used to do the indoor-outdoor detection. It is based on ML models, and it is a problem of context detection resolved by ML-based detection unsupervised models. So just another information to do the indoor-outdoor detection, the ML model use radio signals, standard 3GPP radio signals like RSRP, RSRQ. Thus, the works dealt in this presentation answer the following research question. Is it possible to do accurate environment sensing based on ML algorithm in the context of lack restricted of data sharing, or in the context of massive data and we want not to transfer it? And the second question is it possible to train it with only synthetic data? Sorry, too fast. The work, the main contribution of this work are the following. We have proposed an automatic framework that is able to first learn, then transfer learned, select the best model, transfer the model based on the quality of synthetic data, and then use this model to generate synthetic data for IOD ML model training. And to do that, we experimentally show that evaluation metrics studied are a good indicators of the expected performance of IOD task. Third, we provide a comparative study of 4 distinct well-known generative models and 4 unsupervised IOD models. We show also the impact of the limiting of the training data set size on the quality generated data, and then validate the detection capability of this of using synthetic data only by tracking F1 score of the IOD-ML model. Here, to perform IOD using synthetic data, the automatic framework we propose is executed so as to maximize the performance of Oh no, sorry, there is no, there is an animation, so no problem. To maximize the performance of the IOD classifier trained with the generated data regarding the one trained with original data. The difference between both the performance shall be less or equal than a certain threshold epsilon. Okay, so you can here see the list of the generative models we test in the with our framework, and on the right side, the list of the unsupervised clustering models we test to do the IOD. Before jumping in the result obtained on evaluation of the quality of synthetic data, let's see the distribution of the original source that are pre-processed during the step 1 at the source node. Okay, the data that the remote IOD task plan to use to train the model and then to detect the user environment. So you can see here in the left part the 2D pictures of the two-dimensional signals used by the generative model to learn it. It is composed of RSRQ and RSRP1, and you can see in the left side the 3D picture of these signals. The typical distribution is obtained for a user profile. You can see that because of the presence of the peaks that that signifies that the data set present preferred situation. So habits on cross preferred environments of coming from the users that have collected the data. This data is own Nokia data set that have been collected by the PhD student that is concerned in this investigation. Okay, so here you can see that this step corresponds to the learning of data distributions. The figure depicts the joint probability distribution in 2D, okay, obtained with 4 study generative models. So, okay, you can see that they all look like the original one, the red one. But we notice that it is difficult to visually observe the small differentiation. So to evaluate the quality of the generated data, we need objective and accurate metrics. And for this, we have used first density similarity metrics, 2 types of metrics. First, density similarity metrics, and second, variability and variance metrics that are suitable for evaluating the quality of synthetic data. In this slide, we can you can see the 2 metrics that we used for evaluating the similarity. It is a Jensen-Shannon diversion. Sorry, there is a little some mistake in the slide, but okay, we will correct it later. So the first is Jensen-Shannon divergence, as you can see, and the second is Wasserstein distance for the criteria of similarity. And the second metrics we used to evaluate the data quality, it is the PRG OC that are a combination of precision and recall. Now we can observe the first results, and these results represent the data quality of synthetic data, and these steps is mandatory for selecting the best generator models. And in the pictures in left side, these pictures provide the GSD metric depending on versus of the training dataset size, and the case 100% correspond the fact that we use the force models to learn on the 100% of data that is in the dataset, and then 5% means that we use only 5% of the data in the dataset to learn the one of these generative models. In the table of in left in right side, we have providing all the metrics in the case of 100% for the fourth model for the fourth generative models. And what we can see that there is one model that are very better than the others, and one model that are that provide bad result rather than the other. And the first the bad result is provided by the GAN, but we are not it is not a surprise, because we know that these first generative models have a lack of accuracy and precision, and it can make some collapsion problems that degrades its performance. And the Weierstein GAN is a derivation of GAN, and provides better performance than GAN, so that you can see in the metric that GSD is provide good result when GSD is small, and you can see that in this case it is GMM that provides the better results, and we can see that using this GMM we can have the best result in terms of quality of data. And GAN also, it can they have not it provides not the maximal GSD, but it is a bad solution, because in terms of training time we see that this it went a long time before going to the optimal version of generative model with GAN. So okay, we with this metric data we select based on the quality data of synthetic data generated the best model. Now we have to see if this best model for each model tested generated synthetic data that allows IOD models to perform well. That is the second set of results. So you have also two scenarios. The first scenario provides you the performance given by the F1 score of the IOD model versus the size of the training dataset used to learn the generative model. And then when we have learned a generative model for a training dataset size, we generate 4 sequences, and we generate a sequences of synthetic data, and then the 4 IOD model is used to learn to be learned on this synthetic data. And the results obtained is given in the picture on the right. Okay, we will see after what is the main results. But before that, you can look at the left pictures, and these left pictures correspond of the result obtained with IOD models using directly the original data. As we can see very quickly that the best IOD model when the size is important, it's Cummins and GMM clustering that provide F1 score higher in context of unsupervised learning. And when the size decreases, we can see that Cummins and Birch, the performance decrease, but Cummins and Birch can provide higher results. Now we want to see if the model generative, we can mimic the same behavior, the same performance with the 4th IOD model. So just Cummins, as you see Cummins in blue, we can see that whatever the model, the generative model used, if the size of the data set is high, the 4th generative model performs, provide data data with a quality that allows to Cummins to keep the same performance as if it was trained with original data. For Birch, as you can see that Birch is with the data synthetic generated with all the generative model. Birch provides better, not better, but worst performance F1 score with the synthetic data. So we can see with this two IOD model that with our method, we can provide a generative model that generates synthetic data that maintain the same performance with the IOD models test. And what I want to see, it's our objective was not first in this evaluation was not to enhance the performance of the IOD models. We want only to see if we can maintain the same performance using only synthetic data instead of the raw original data. And we see same type of results with 2 other IOD model, GMM clustering and DEC. And as you can see, we have the same performance with synthetic data when the size of the training data set is high and when the size is decreasing. So I don't know. Okay, that's all. That is the main results that have been presented in this investigation. So thank you for your attention, and if you have questions, and there is a reference of the paper linked to this investigation.
Thank you, Marine, for your presentation. So, if there is anybody with a question for Marine? Otherwise, I will start. So yes, it's maybe more, let's say, some philosophical questions. So as you say, that your goal was not to improve the accuracy. So at some point, is it good to have better accuracy with the new generated data for the training? Or is it bad to not have been able to reproduce the same results? I'm not sure about the answer personally.
Yes, I know that it is very strange to say that, but okay. The first, the main target in using generative model in this use case is to avoid to transport the raw data. So we guess that we are able to learn the generative model, and the size of this generative model is less than the size of the massive data required to collect and to transport, to train the IOD model. And the target is to gain in the resource constraints to collect massive data, and then we avoid to do that. We learn generative model, you transfer it, and then we generate synthetic data and use it to train the IOD model. And we will see that doing that is the quality of the data is enough to provide the same performance with the ID models than the scenario where we will use the original, the source data. So that's why this these results is for us good results, and okay, that's all.
Okay, thank you. Just another question, and then give the floor to other ones. Maybe if you go back to your slide 10, it will be easier to discuss it.
Yes.
So you have all this pipeline basically. So basically your approach is to apply the different generative model and see if, as you said, if actually you have been able to maintain the performance. I was wondering if now in future also looking into the let's say somehow the backward passage, so that based on the result it produced, you could be able to better somehow parameterize the generative model you use to synthetic or to selectively to generate more, let's say, selective synthetic data that will be the ones that are needed to maintain or improve the
yes
performance.
It requires it requires a feedback maybe. Yeah. I see two solutions of that. First, a feedback from the remote node, or some sort of kind of indicator of what type of data requires the IOD classifier to perform the detection. And the second solution is to have, if we can have a feedback loop, because when you have a feedback loop, it introduces some latencies. Okay. In the second solution, you can have an a priori, maybe, of the quality of data required to perform the learning of IOD classifier. But it is yes, it's an envisaged solution to enhance the way to select the best or the optimal generator.
Okay, good. Thank you. Laura, I will let
You're welcome.
Yeah, thanks, Marilyn. I have maybe two questions very quickly, maybe on slide 17 or some of the result slides, just to understand a bit better. So if I understood correctly, it means that you could push the training of the generative model to work on relatively limited training data set size, like nearly up
Yes.
to 10%, and still match relatively good detection rate in the IOD.
Yes.
So there is still some. I mean, it's still significant gain that you can have in terms of how much you rely on the original training data set. That's the correct understanding of the result at this point?
Yes. Okay. I have yes, it is a correct understanding. I don't have some measure of how is the minimal size, if it is your question. But what I can say, this is not magic. We maintain the performance of the IOD model when the size decreases, because we are in the scenario where no, here we are in the scenario where the diversity of the situation met in the data set is diversity at the degree of the profiling of one user. It is like it is a scenario where we have one IOD model per user. Then we track then the data set used to model to learn the IOD model is a data set corresponding of data collected linked to one user. So when you reduce the size of the data set, you maintain a certain level of enough of diversity. That means that the model the generative model you learned continue to generate data with good quality for the learning of the IOD models. It is clear I answer to your question?
Yeah, I mean, to some extent, yes. Thanks. The other thing, and I don't know if because you don't have this in this presentation, but one of your assumptions at the beginning was to say we want to be able to kind of transfer more the model or descriptor of the generative model to save on the amount of data we transfer. Are you working on evaluating how much, saving you can get from that, or you already have results?
Yes. Well, yes, we have some. We continue the investigation, and we have evaluating the resource gains of using generative models instead of raw data in the transportation.
Yeah, I'll be interesting to have more insights on that. But
Okay.
that's more side discussion.
We can do that in Nokia.
Yeah, thanks. Rashmi, I think you're.
Hi, Marilyn. Thank you. Thank you for your presentation. It's actually interesting and in line with some of the work that I'm trying to actually do. So have you tried to actually use generative model to actually on different type of data sets than what you have? In other words, can we actually generalize this approach of mimicking the behavior of the raw data and into a generated data, and then do the evaluation on the generated data altogether? Do you think we can actually generalize this?
Okay, so we have tested it with other type of data set. I don't show the result because it is data set that have been contract between Nokia and other companies, so results can be exhibited externally like that. But what I can say of this type of data set, it is a data set that are very different, that are our own data set. It is data sets that have been collected worldly. So it corresponds to a data set that provide a very high diversity of situation of environment types. And what I can say is that it's okay here. If you when we picture the 3D shape of this data set, we can see that the shape is more like Gaussian bell, and then the generative model we use to learn this data set provides better results that this type of distribution, and we maintain the same type of results, that is when we are able to select the best generative model that are able to provide data with the appropriate quality for an ML task. You can use the generative model to provide synthetic data and then train your ML task. So we have tested in other data set, in other scenarios.
Yeah, that's good. So that's one of the things in my to-do list, actually, to send a miniature model to dataset nodes, and then have them basically train those miniature model based on synthetic data, and then provide me with a score that I can then evaluate to see where the actual model can better go to achieve its performance objective. So that's what I'm asking. If I can generalize this would be a very good results, actually, as you can see.
Yes, but the main constraint is we should be able to do that with a minimal size of generative model.
Generated data. Yes.
Otherwise, it's not. There is no gain to do that.
Exactly. Yeah.
Yes. See, you can have the gain of the privacy, data privacy, because originally, generative model was used to in medical or security or bank application to send data without in preserving the confidentiality of the data. So it is almost the same idea, the same concept, not sending the data, but rather the generative model. But in this case, we have to provide minimal size, generative data with minimal size.
Right. Yeah, because the computation cost is a factor as well, right? So, yes. Thank you very much.
You're welcome.
Thank you very much, Marine, again. We will continue with the last, I would say, not the technical question, but last part of the meeting. That is a short wrap-up and open discussion. I know that we have a bit we extended the time for presentation, but it was very nice to have all these discussions. So Hello, can you hear me?
Yeah, now
Yes.
we before.
Oh, okay. I think I was
Yeah,
muted. Muted before. I think. Anyway, so so yeah, just for the last part of the meeting, I was saying that we have a small wrap up of the discussion in NMRG, but with the main also to have an open discussion regarding the activities that we can continue or convey within the group. So maybe this slide is just kind of summary of what has been done related to this topic of data or data quality. Just maybe as some of you might remind, in the past and in years before, we had a lot of workshops and flow-based network measurements. So we are also talking about data, but more about how we can use data that we collect in network for monitoring. And of course, with years and with the let's say the widespread of AI in network management, networking in general, with all presentation related to the use of machine learning in the group, but in other, of course, for us, there was a lot of discussion with the problem with data of bad quality, data that we do not have access to data with without labels, and so on. And this discussion, of course, it was a kind of never-ending discussion, and so we try somehow a bit to in NMRG to also formalize a part of this issue in the document related to the AI challenge for network management. So here just a very small extract. In this, we are discussing what data to collect, for which problem. I think it's already some presentation today. Oh, we can collect data. Oh, we represent the collected data. So again, it's also relates, for example, to the data descriptors that we have been discussed. How to make data usable. And here we have a lot of questions about the quality, but also we have also highlighted the problem with the compliance with laws, regulation, but also of technical problems to access or to manipulate the different data. So this we have in this draft that is under revision, and we also started to, of course, be beyond this simply, let's say, things that there are issues and challenges. We try also to organize a bit the discussion to also to progress on that. And recently, so last IETF in last November, we have already a series of 3 technical talks on data quality, and I think all the presenters are here today. And just maybe a kind of summary. So Jose has presented first a presentation that was about highlighting the importance of the problem of data quality and its impact on the performance. So I try to somehow really highlight and somehow scope the problems in the problem of anomaly detection. Omar was presenting a method to how we can enhance the quality of the test set. So that is a bit different than what we have here today, for example, for the training sets. So there are complementary approach, how to generate a test set to improve the evaluation of, in that case, of intrusion detection system. And so Gregory was also presenting his work that also is working with Benoit that presented today on how we can better enhance the evaluation of intrusion detection systems. So Gregory has presented different pitfalls and lessons that are known or that have been documented, and also set a nice set of open questions already. So about the formalization between of the relation between data and detection performance, of the quality of data, can we assess it universally, or does it need to be in respect to the detection, as it was again in the context of intrusion detection? And also asking, can will it be possible to somehow escape from the lab and have real data? So this today we have another set of presentation that I think are also quite complementary, because, as I said, we have seen different, let's say, way to we are discussing a lot about how we can measure the quality of data, depending not only on the data intrinsically, but also on the model or the problems you want to resolve. So either at the last presentation was, for example, the quality was related to the quality of the training of the model that is trained at the end when you generate training data. So this is really related to the performance of the trained model with synthetic data. Some other were presenting about the Benoit was presenting about the diversity of data to have a more diverse representation of data when you test intrusion detector. And also, I think I actually make a very good connection as well during the presentation. We discussed a lot between the connection of the measurement of data quality that by itself is not so relevant if you are not considering the problem. And yes, thank you, Laurent, for the notes. We have also in previous session at IETF 116 some presentation on data quality assessment. Also, to make a bit complete what is the current status, as some of you know, we are also still working on this updated research agenda of NMRG. But I think after long discussions, I mean, there is not so much discussion anymore. So I think it needs it has been refined already a lot. There is a part about the data quality. And then you see we already drafted some, let's say, possible orientation of the group regarding this problem. One is about the, of course, the methods and metrics for assessing data quality for different network management application. Are we able also to collect data with the expected quality rather than just evaluating always the quality or a posteriori try to have quality by design? And also some part can be more, let's say, about the reviewing the quality of the most used data set in research. And yes, there is some parts that really relates to the presentation today, because here we are also in this future research area, we were also drafting some proposition on the description of the data set to identify, for example, if a data set can be applied to one network management AI-based solution, where about highlighting the difference in formats, models, and semantics that can be used for description of the dataset, and maybe also a telemetry framework of data enablers for network automation. So yeah, I think here we just like maybe then to leave the floor for more comments or discussion. But the idea is, as I think there are a number of people that have expressed interest or presented things related to data quality or the data, I would say, issue in general in the context of network management. There are possible questions that we could maybe try to answer collectively, I mean, by working together or by providing feedback to each other regarding the different questions that are here. I mean, not just I mean, not read them. You can see them, but of course, this is really open note to also what people hear and people usually in discussion would like to also do and work, and also what type of outputs you would like to have. This can be a research paper, white paper, can be a draft, can be that we continue with this type of workshop. It actually our interim meetings that have been very, I think, great in terms of discussion, because we had time to discuss a bit more the technical part and scientific part of each presentation. So yeah, this is basically all my all things that I wanted to share with you. I let Laurent, if you want to complete, otherwise just leave the floor for comments and to everybody.
Thank you, Jérôme. I think you covered all the items we wanted to express today in terms of open discussions. I'd just like to stress on one element because we have quite a number of, let's say, presentation and work that are related to data and data sets, especially in the context of machine learning, which is an obvious connection. But I think in one of the points, we have also the fact that, especially network and network management, we can have data and use data not necessarily only to train machine learning models, but also for the purpose of operating a network. So I think we need to use this mainstream approach of data for machine learning. But I think we should not neglect also that data quality and the use of data, how we collect and how we ship data, can also work without machine learning in the loop, and also be of great importance, this quality and what to measure, where to measure. So this is still an important topic, I think, for network management. But maybe to connect with the discussion on, I mean, this open discussion, really it's an open flow. What do you think, I mean, what would you like to do together? Do you see that we should try to concentrate on one sub-aspect? Do we want to work on testing things or implementations? Do you want to host workshops? I mean, what will be useful for you to go to the next step with these questions?
So I think the workshop actually is probably a very good venue. But aside from that, I was wondering if coming up with a draft to outline the requirements for data descriptors. I'm not talking about actually implementing it. What needs to be expressed in this data descriptors might be a good venue to start a collective work on this thing. And then discuss this over different workshops and start basically maturing it over time, and eventually get the research community to work on the actual solutions to get those metrics in the descriptors, basically. What do you guys think about that?
I agree on that view. Can you hear me? Yeah. I agree that the draft, that would be my choice. And in general, I'm very critic with the research directions that you can find in journals and even in top journals and top conferences, where most people is concerned about the performance of a model, but it's not really tested in an environment that is kind of realistic. And what I found when we try to do something hopefully different in our own research and try to publish in journals, then there comes this reviewer who is really concerned about the general trend. So I think it would be easier to convince the industry that these are topics that are relevant, and that sometimes research papers are not really, realistic to that extent. And then from that point, for sure, go to conferences and other stuff. But I think the draft is the way to go, but you have much more experience than me on that. So maybe, I don't know, that's my opinion.
Well, my point was that I want to actually use a draft to direct the researchers and basically say, okay, so these are the basically requirements that we need to focus on. And now, based on these requirements, people can actually go and conduct their research and tackle different aspects of the requirements, and hopefully come up with some solid solutions there. That's what my objective, at least from the initial draft, is.
Yeah, no, I agree with that. That's different. But starting from a research paper is kind of more complicated because of the trends I was discussing.
Right. So Laurent, Jérôme, do you guys have any objections to creation of this type of drafts and proposing some sort of requirement draft but the only concern that I have is that this draft will not be specific to network management. So that might be something that the IETF might consider when issuing the draft, or accepting the draft, or allowing the draft to be discussed or something like that. So we have to take that one into considerations.
Yeah, clearly yes. But regarding the draft about that you mentioned about the requirements, yes, I think it probably can go beyond, of course, network management. Does not mean that at the beginning you can start working on this, and it can be, the kind of bootstrap. You can bootstrap here, and then depending on how the draft evolves, it may go somewhere. So I don't think this is critical in that sense. Of course, it's better maybe to focus the right, let's say, groups and so. But if you have here some support about that, I think it can be good to start here. But yeah,
sure. Yeah.
So just to highlight here, I think as you say in the beginning, you say about the requirement wide, but you rapidly, if I understand well, you say that it will be just to highlight the different challenges and so. So it, in my opinion, also as not only as of course an NMRG co-chair, but also as the other participants, it could be a requirement, but not in the sense, of course, of technical requirement, but maybe objectives. What the requirement in the sense of what the data scripture should allow to do, so that it can give some of the ideas or directions for researchers how to build methods that can perform this afterwards. It should not be, kind of requirements in terms of formats or whatever, of course. Right, so more requirement, or I would say more objective-oriented requirements, I would say.
Yeah. So some maybe what we can do, or at least I try to do when we come to Bangkok, we try to socialize with others and see who are interested in participating in this draft, and then create an initial outline of the draft to see what we want to capture, and then share it with the group and see what people think. And then we'll take it from there.
Yeah, and of course you can already start. Of course, based on your available time, you can already start discussing a mailing list, and see also, because here we have only a subset of people who might be interested in that. So do not hesitate to share your ideas as well on the mailing list.
Right. Okay.
Yeah, I think it's an interesting path to take, and maybe just to stress it again, but I mean, we as chairs, we don't control if you want to submit something. You see, it's an open forum, and we are here to guide the group. So it's very much welcome, and that's the purpose of a draft, to put some initial ideas and collect feedback, try to see who wants to contribute to that, and get also different views. So I'm really supportive of this STEP approach.
All right, great. Thanks, Laurent. The other thing I was wondering was that the appetite for a common platform, or like a test bed or something like that people with ideas can actually come and try their algorithms or approaches in there and see how it works. This will basically provide a common way to evaluate these different algorithms for as people come up with a different way of data descriptors and things like that. If we can come up with if we can provide them with a platform that allows them to evaluate their ideas there commonly and see what works well, that might actually work as well. I'm not sure how to go about it though, because one way is through the hackathon, but I don't know whether we can actually bring GPUs to a hackathon, for example. It's expensive to actually but that was another venue that I was thinking about, but I don't know how to really go about it.
Yes, I'm not sure what is meant here by the algorithm that you would like to see on this platform, but yes, if you're thinking about computational platform with the GPUs and so, a way to do that today is to use, let's say, open, SAS platform, so that you can use. And there are many that you can use. You can publish. Depends your model, your data set. So there are different. So I think it is an interesting. Also, I think an interesting direction. Maybe what we would like to maybe somehow maybe publish in this type of platform will be data set, will be models, will be different stuff. And then we can discuss if we would like to somehow create a team in the sense of this type of platform. What I mean in mind is all these Hugging Faces and other data bricks and so, and trying to create also some kind of community there, because of course there are also a lot of things going there as well. For sharing this.
Yeah, I also think that I mean, just on the talks that we heard today, that for instance, I see some connection, for instance, with what Marilyn has presented, which is, I would say, kind of specific techniques, but more, I would say, use case oriented. In, for instance, what Ashmid you presented is more like a bit of a framework, and I think you could try to see how, for instance, Marilyn's work will map to a kind of data descriptors and topology descriptor, and see what could be an illustration of the concept that you represented in a more concrete setup, and then see if we can kind of generalize in the sense of having, we were talking about this kind of platform or environment. If we go for a certain approach like moving models to data and data descriptors, from different users' perspective, maybe IDS or security use case could be another set of users.
Right, absolutely.
Yeah,
absolutely.
Then we can demonstrate that the base framework is useful to several use cases, and that's a bit what I think Jérôme was advocating, to say this can create also this notion a bit of community and raise the interest. Oh, there is something that more than one person is actually pushing for.
Right. So I will actually talk more about the platforms that we have in our lab and what the vision is. And I'm going to actually, once you actually read the paper that we are trying to submit to IEEE magazine, it might actually pave a way for what we think the platform will look like. And one of the things actually I latched on Marilyn's presentation was that we are actually in the process of creating generated data set and evaluate that for model performance and come up with a scoring mechanism to allow us to identify the nodes that the machine has to go and traverse in order to achieve its optimal learning. We have one data set, for example, right now, and we have a couple of algorithms that sort of work based on mini batches. However, I'd like to actually expand that and go through different data set and see whether the algorithms that we came up with, they can be actually generalized to different data sets, or they are specific for this particular data sets that we have been using. So I stay tuned. I probably come up with or provide a presentation in Bangkok when we are here, and before that I put the slides probably in the mailing list for people to actually take a look and provide comments.
Okay.
We still have a few minutes in the meeting. Do we have views from others? I mean, or other, path that will be of interest to continue in the context of the NMRG for other aspects of these data questions?
In terms of order, I think the first question is basically the most important one: how to measure and assess the quality of data. But I would say, with respect to models, because again, the model is another factor that we have to consider as well.
Mm-hmm. Thanks. Jérôme, I mean, okay, this is just one example, but I think that there is the supervised project that is a bit looking into, can we characterize data quality in a general way? And I think that they had a workshop recently, so maybe some of the learnings that they can get from that could be contributed also maybe for discussion in the NMRG. That could be something to go along the point from Arashmid.
Yes, I think I understand the point raised by Arashmid regarding the quality must be assessed related to the model. What we are trying to do in Supervise, what has been presented is not on the model, but on the in the case of Supervise, on the objective that is intrusion detection. So because you can use different models with some other main aim, the same target, that is to detect intrusion or detect attacks, and you try to have a data set, and you try to that can be used for all these different algorithms that are used for the same final objective, I would say. So this is kind of I think different approach. So I think it will be also good to continue to discuss that, because here it's more about somehow measuring the quality of the data, not in respect of the model, but in the respect of the final output of the application. That is a bit different.
Maybe for complementing what you are saying, what we explore in the past, and we have this paper eternally under review, is to use models, but let's say a bench of models, so a group of models to, and some, what we do is basically use resampling techniques in order to identify to which extent the data is really consistent with the goal that you have for data science application. So it could be anomaly detection, but it could be classification, it could be probably regression as well. So you use these bench of models, kind of a proxy of, because if you use several models that are quite different, you have kind of a general view of how the data is really meeting your goal. It's a little bit maybe complicated concept. I don't know if Kasia presented it in the past in this venue, but it's something we have developed a lot in the last years, and I mean it's one way to do it, but very computationally expensive. So I understand that some additional research is needed on that.
Mm-hmm. Okay, good. So thank you also, Jose, for your comments. So I think there is clearly some follow-up that will happen regarding all this discussion on quality of data as well. So I don't know if there is also a views before we close the meeting.
Thanks, everyone. Also, maybe because people were a bit mentioning Bangkok, I think it's important also to try to use the mailing list or share things a bit ahead so that we can loop in as many people as possible beyond the interim meeting or the face-to-face meetings. But it seems like a very interesting research stream, and I'm really looking forward to see what we can do on that.
Okay, so thank you everyone, and to you soon, either in person or online.
Thank you.
Bye.
Thanks, everyone. Thank you very much.
Thank you.
Thank you. Bye.
Thank you. Bye bye.